Hi there. In the previous video, you've looked at what a 2D array is and how to create a two-dimensional array and how to run a loop. In this video, we are going to solve a problem. The question is, you are standing on the upper left corner of a tiled floor containing black and white tiles. The left upper corner is always a black tile. Your job is to move around the floor stepping only on the black tiles. The course of movement is given as follows. So this is your starting point. This is where you start, and this is always the black tile. So you move downwards or you move down the rows in only stepping on the black tiles, which means if this is I, you move I plus 2, okay? And when you reach a dead end, you move to the next column. Now, there's one thing that you have to notice that if the floor has odd number of rows, like for this one, this particular floor has 5 rows. Then after hitting the dead end, you move diagonally up. And if the floor has an even number of rows, after hitting the dead end, you move diagonally down. So this is one thing you have to be careful about. Now let's get started. Let I and j be two pointers. Let I point to the number of rows and j point to the columns. So initially they are both zeros and they are over here where you are standing initially. So according to the question, I have to move I downwards until dead end. As I've mentioned before, according to the two diagrams, the dead ends are different. So if I plus 1, for this diagram, if you look carefully, if I reaches the last box and if I plus 1 is out of bounds, which means beyond the number of rows, beyond the number of rows, then we are sure that the number of rows is odd. So it means the floor has odd number of rows. And if I plus 2 is out of bounds, then the floor has even number of rows. So in the previous lecture on 2D arrays, we saw how to run loops. In order to solve this problem, you also have to run a nested loop, but in a slight different manner. Can you find it? Moreover, the pointer I will move downwards first and then upward. So I moves downward first, and then when you move to the next column, it moves upward. Then again, when you move to the next column, it moves downward, and it goes on like this. In order to solve this problem, whether to go up or whether to go down, you can take a flag initialized to 0. So if the flag is odd, which means if the value of flag is 1, 3, 5, 7, etc., we can say that we have to move up. So if flag is 0, I is moving downwards. So you move to the next column, you increment flag from 0 to 1. 1 is an odd number, it means that I should move up. Okay? So we can use a flag to determine whether to move down or move up. Now let us put together everything we understood so far. So we will be given a matrix, say M, and we can find its rows and number of columns using the shape property. So we can just write m.shape and it will return me a tuple. We have already seen this in the previous lecture. And then we'll be taking a flag initialized to 0. Then we have to run nested loops, right? So loop 1 and loop 2. So if this is my floor, so we are initially over here, and as flag is 0, and which is not odd, so if flag is 0 and even, I will be moving downwards, which means I will be +2 at each step. But before I do this, over here, I must do the check whether I have reached dead end or not. And the check for dead end is I've already shown it in this slide that I have to check if I plus 1 is out of bounds. If not, I have to check if I plus 2 out of bounds. And if these two conditions are false, it means I can go further downwards. Okay. And else, if flag is even, if the flag is odd, it means that I will be going up, which means I will be decrementing 2 steps. And before I do this over here also, I need to check for the dead end upward dead end. And it's very easy. If you look at the diagrams, so one dead end is always over here. So I plus 2 is out of bounds. And the other dead end is I plus 1 is upper bounds. So very much like this one over here. So let me mark red where you have to check for dead ends. So over here and over here. So in other words, before you move down or you move up, you check for dead end. And if you have reached the dead end, you move to the next column. If you have reached dead end, move to the next column. All right. So let's clean up and write again. So this is the function. Let's say I have a function f where I'm given a matrix. I take a flag, initialize to 0. I take pointers, I and j. Initialize to 0 as well. Then my first loop starts. And it is your job to figure out what to put over here. And my second loop starts here. And then I check if flag is 0 or even. If flag is 0 or even, I do my check over here. If I plus 1 is out of bounds, okay, so let's say this is my matrix and I is over here. If I plus 1 is out of bounds, then if true, then we move to the next column and change flag. And if not, say if I plus 1 is not out of bounds, I have to check if I plus 2 out of bounds or not, because I might have a matrix with even number of rows. If I is over here, this condition will be false. So I have to do a check here again. Else if I plus 2 is out of bounds, then do the same thing. Move to the next column and change flag. And this part else means if flag is an odd number, that is, let's say I is over here now. So flag it will be an odd number. In this case, I will move I upwards, which means I will be decreasing. But before I decrease, I have to do the same checks like this. That if so, I plus 2. So if you look at the diagrams, whenever we are moving up, this is always a white space. See? Therefore, just one check would be enough. So I'll just check if I plus 2 is out of bounds or not. Or not. If true, then move to the next column and change flag. And if false, then continue. Same for these, okay? If these two conditions are false, then I'll continue going down, okay? Same here. If this condition is false, I continue moving up. So going down is I plus 2 and moving up is I minus 2, okay? And why 2? Because I cannot step on a white tile. I have to skip. Okay, I hope you've understood how to solve the problem, and how to code is your job. Thank you.